Hey there, this is a lesson for 1.3 section from our book. It's called Solving Equations with Variables on Both Sides. Oh, sorry about that. Our opener today is going to be spot the error, so you need to look at these two problems and figure out where was the error I made in solving them, and then I want you to also fix the error as well. So make sure you're doing that in your books. Alright, our learning target today is the following. I can solve, again we're saying that word solve. I can solve linear equations in one variable that have variables on both sides. This is the difference piece right here today, is that we're going to have x's on both sides of the equation now. And then secondly, we're going to also have another learning target of I can identify equations with infinitely many or no solutions. Here we go. Alright, so this is what I mean by saying there's variables on both sides of the equation. So on either side of that equation. So we're going to treat the same way. We want to get all the variables on one side and all the constants or all the numbers on the other. So in this case, I'm actually going to add the 4x to both sides. Just like before, if you add something to one side, you have to add it to the other side. So it's going to leave us with 10 is equal to negative 5x. Divide both sides by negative 5. And our answer becomes x equals negative 2. Obviously that first example is pretty easy. This is where the examples start to get a little more intense. Now, you can look at something like this and get worried about it, or you can just take it one step at a time. So the first thing I would do for each of these is I would distribute these. Meaning I'm going to multiply whatever is on the outside of the parenthesis by everything on the inside of the parentheses. So 3 times 3x is going to be 9x. 3 times negative 4 is negative 12 equals 1/4 times 32 is going to be 8x plus 1/4 times 56 is 14. Okay. Now, just like we did before, we're actually going to move pieces around. On this time, I notice I have a positive 9 and a positive 8. I know that 9 minus 8 is going to be 1, which means I won't have to divide. So that's why I'm actually going to do it this way this time. Subtract the 8x here. And then I'm going to be left with x minus 12 equals 14. I'll add the 12 over. And x is going to be equal to 26. Again, things can get more and more complex. These are just more examples to help you guys see how to do things and think about ways you could try to solve problems. These are the examples that are going to either have no solution or infinitely many solutions, and we're going to talk through how we get there with these. So the first thing I want to do with this problem here on the left is I see that there's a 3 times here, so I could distribute, but I also know that 15 can be divided by 3. So I'm actually going to start with dividing by 3 on this one. That's going to leave me with 5x plus 2 equals 5x. Now again, because I want to get all the x's on one side, I'm going to subtract the 5x over. So here I'm just going to subtract 5x from both sides. And now I'm left with 2, which is equal to 0. Obviously, that's not true. So this here is actually not equivalent to it. Meaning, this one is going to have no solutions. There are no values of x which make this true, because as you simplify it, you actually get down to 2 values that are not the same. Looking at the other one. again, I could actually do that divide by -2 again, because -8 and -2 have the same, are both divisible by 2. If they weren't, I couldn't do this right away. So here, and actually I'm going to not do that one and that one. So I'm going to take this, I'm going to distribute this again. So when I distribute this, I get -8 y minus 2 equals -8 y minus 2. So you might notice something weird on this one. It's exactly the same on either side of the equation, meaning that it doesn't matter what you plug in here, you're always going to get the same numbers. So this one is going to have infinite solutions. Again, just to recap, no solutions occur when you simplify and things do not equal each other. Infinite solutions occur when you get the exact same pieces on either side of the equation. Alright, again, we're just going to look through this problem and just see how they did it. So they're saying a boat travels upstream for 4 hours. The return trip takes 2.8 hours because the boat travels 3 mph faster downstream due to current. How far does the boat travel upstream? So they're going up the river and down the river, meaning they're doing the exact same distance, and that can be kind of hard to tell right away from the problem. So because we know the distance is the same, the only thing that changes is how fast we're going. We know the time, so we can actually use that rate equation again. Rate times time equals our distance. But because they're both the same distance, we're actually going to have two things of rate times time equaling each other. So on the way up, they're going for 4 miles or 4 hours. So we're just saying, hey, a mile an hour. How many is that? We're going to figure that out here. On the way down, we're going a little bit faster. That's why we have the x plus 3. So we'd be left with 4x equals 2.8, which was our time. So notice how we have time in front, times our speed. Once we simplify, we'll get it all the way down to where x is equal to 7, meaning that we traveled 7 miles per hour for 4 hours. Thus, notice how the answer is not 7. The answer is actually 28, because if you've done it for 4 hours, like we said, we went up the stream for 4 hours. We're just trying to find the rate per hour, so you could just multiply to get back there. Alright, today's homework. It's on pages 23 and 24 in your book. Numbers 1, 2, 4 through 34 evens. So that's really, while it looks like 30 problems, it's only 15 problems there. Number 38 and 41 and 40 through 44. This is 21 problems. It'll probably take you about 25 to 30 minutes to finish. Our closer for the day. Remember that next Wednesday you do have our first quiz, followed up by our discussion post on Canvas. I need you to pick one of the problems from 4 through 34, and I want you to make a full video. You can make videos in a couple different ways, so be creative, and I just want to see you starting the problem to finishing the problem.